All right, here's our next set of notes talking about fuel types and their various uses. This is something we covered in class, but these notes are a little more in depth. Also has pictures. Fuel types. Wood is a very common fuel type that's used as a cooking fuel and also used for heat generation. Especially in areas where you don't have a lot of alternative sources, like you don't have access to natural gas, you don't have access to electricity. So, like I said, it is used as a cooking fuel and for heat generation. All right. Then there is something called peat. No, not the person peat. It is partially decomposed material. It tends to form in areas of high acidity. And I have seen an AP test question that asks about that. Under, hold on, under acidic conditions. So here is how peat is formed. By the way, this is peat being burned. It's these brick-looking things. Those are actually partially decomposed matter. So in Ireland, here is how peat you had basically some nutrients being, lost from the soil. Things died. It ended up having some plants grow there, heather, for example, which turned the ground acidic. And then undecomposed material just stays there. The acidic conditions help keep it from decomposing, just because it's less of a favorable environment for bacteria, so they can't decompose it. This stuff builds up. It turns into peat because it's not digested, and eventually people come and they cut it for fuel. This is not coal because it has not been turned into a sedimentary rock. So it hasn't been exposed to the heat and the pressure. Notice process takes less time than the formation of coal. Looks like this process took about 6,000 years. So it's more of a renewable resource than coal, but it's also not as energy dense, meaning it doesn't have as much energy per kilogram of mass. Now, what is peat used for? It's used for cooking and it's used for heat. Same things that we burn wood for, we can burn heat for. Coal is a fossil fuel. It takes hundreds of millions of years to form. So, what happens is you have something like peat, which is partially decomposed organic material that is exposed to heat and pressure over time, and it eventually becomes coal. There are different types of coal. For example, there's lignite, bituminous coal, and anthracite. Now, they're different in the energy content that they create, and they're also different in the amount of time they take to form. So, as as peat gets exposed to heat and pressure, first it becomes lignite. Lignite tends to have less heat content, which means that it's not going to produce as much energy when you burn it. With more heat and pressure applied, it becomes subbituminous. Then, as more heat and pressure are applied, it becomes bituminous. And the highest heat capacity type of coal is called anthracite. If you have ever get a chance to see samples of coal, they even look different. Anthracite is a little heavier and it even looks shinier. If you are trying to burn coal for electricity production, you really want bituminous or anthracite. Lignite just doesn't generally burn hot enough for that. So, the differences in heat and pressure, the depth of at which this material has been kind of buried underground, are all going to affect what type of coal is being formed. Eventually, if you have lignite or bituminous coal and you keep it underground, keep subjecting it to heat and pressure, eventually it will form anthracite. Natural gas is usually going to form with oil. It's mostly methane or CH4. It's called the cleanest of fossil fuels, but it's still going to produce CO2 when you burn it. So, not coal, natural gas and oil formation happens very similarly to coal formation, but it happens in the ocean. So, things die in the ocean, they sink to the bottom of the ocean, they end up getting, they're not fully decomposed, or they're only partially decomposed, or not decomposed at all. They eventually get buried under layers of sediment, become a sedimentary rock, and they become oil and natural gas that ends up trapped in these layers of rock that we can, if we drill, eventually get out. So it's often found with crude oil deposits. Crude oil is petroleum. It's a mix of hydrocarbons. There's a lot of different substances in crude oil. And when we talk about fossil fuels in more detail, we'll talk about what some of those substances are and how they're purified. But it's you can drill it from deposits underground, but now that we've used up a lot of the more easily accessible oil deposits, we're having to turn to more alternative methods. So we can get oil from something called tar sands or oil sands, which contain an oil called bitumen. And we can take bitumen and convert it into a kind of synthetic crude oil. We can also use, so that can be done either by surface mining or by what's called in situ or in on-site extraction. And there's also something called hydraulic fracturing or fracking that can remove oil from something called oil shale, which is a type of rock that doesn't have like a separate deposit of liquid oil. Instead, the liquid is kind of incorporated into the rock, and we can extract it from that. We'll talk about both of those methods with fossil fuels later. Fossil fuels can also be turned into other types of fuels. So, for example, you can take them to use as, you can convert them to something like gasoline or liquefied natural gas, which can be used to power a vehicle. Gasoline, diesel, jet fuel, those are all produced from crude oil. And then there's another thing that can happen when we're burning these different fuel sources. So, when you burn something, it makes heat. That heat, in the case of most forms of electricity generation, is used to produce steam or some other fluid and make it flow. But that steam will then have to be cooled down to turn back into water. So, what you can actually do is you can take that steam or hot gases and you can use them to heat a building. So, this is actually a diagram from MIT where they were talking about using building a new power plant that could not only generate electricity, but could also co-generate heat at the same time. This process is called cogeneration. Co means together. So you are producing both heat and electricity together using the same fuel source. Remember, when you do energy conversions and you're converting from, say, kinetic energy to electrical energy, some of that energy is going to be converted into heat. And so instead of letting that heat energy be lost and unused and just kind of released into the environment, you can use that heat energy to do other things. You can use it to heat air. So that way you can heat a building. You can use it to heat water in place of a hot water heater. Or there are even some systems where you can pipe hot water under the floor of a house, and that will help keep the place warm, which would be really nice when you're walking around in bare feet on a, tile floor. So that's it on fuel uses. Your next set of notes is either going to be fossil fuels, or it might be on where and what parts of the world, and also just what geologic formations do we find some of these resources in.